In recent years, more than 50% of OSHA's inspections have been in the construction industry. Since scaffolds are used at most construction sites, OSHA developed this video program to aid compliance officers in conducting inspections. We have consulted with COSHOs from regional and area offices and the scaffolding industry to help ensure that this video will be beneficial. Scaffolds have been in use in some form or other since people began to build structures. It's likely that some form of scaffolding or work platform was used in constructing the pyramids of Egypt, as well as the Great Wall of China. Today, scaffolds continue to be used in almost every type of construction. As far back as 1915, scaffolds caused enough safety problems in the United States to prompt an insurance company to publish a book titled Safety Engineering Applied to Scaffolds on Related Safety Hazards. This publication described scaffolds in use at that time as being badly designed, often constructed with inferior materials, dangerous, and unfit for their intended use. Regrettably, that description is applicable today. In many instances, things have not changed that much. There have been improvements over the years in the design and in the components of scaffolds. As new designs and technology change the work environment, improvements and/or modification of work practices and regulations are required to reflect these changes. And because the scaffold industry is so fluid and the need to keep current so great, the OSHA Scaffold Standard, Subpart L, is presently being updated to reflect some of these changes. This video training pertains to basic scaffold requirements found in the current standard, general provisions of the proposed standard, and some of the critical items to look for during an inspection. Compliance officers should carefully review the new standard when issued to identify any specific technical requirements or changes. Let's take a close-up look at scaffolds, how they are made and used. Since the 1930s, metal has been the preferred material used to construct scaffolds instead of wood, making scaffolds lighter, stronger, and easier to assemble. Despite these improvements, many injuries and fatalities still occur due to improper assembly, disassembly, and use of scaffolds. Considering the wide variety of scaffolds in use and the hazards they pose, it isn't surprising that a recent OSHA study showed that 20% of construction deaths were due to falls from scaffolds or elevated work platforms. Compliance officers must be familiar with the requirements of the standards and pay special attention to scaffolds when inspecting construction sites. To make it easier for compliance officers to target inspections toward the most likely areas of scaffold failure, we will look at how some of the more familiar types of scaffolds should be constructed. Let's first look at the tubular metal frame scaffold, the most popular and widely used type of scaffold found on construction sites today. The tubular welded or fabricated scaffold is a sectional frame type scaffold consisting primarily of end frames and cross braces. Scaffolds must be properly braced by cross bracing to secure the vertical members laterally and must be of such length as to automatically square and align the vertical members. Proper cross bracing will also ensure that the erected scaffold is plumb, square, and rigid. Scaffold legs are either set on adjustable or plain bases, which are placed on mud sills or other foundations to adequately support the maximum intended load. If built more than one section high, the scaffold frames must be placed one on top of the other with stacking pins to provide proper vertical alignment of the legs. Where uplift may occur due to wind loads or hoisting operations, make sure that the end frames or sections are locked together. When erecting scaffolds, the vertical height must not exceed 4 times the minimum base dimension. If the height exceeds the 4-to-1 ratio, the scaffold must be tied to the building or structure at each end and at intermittent intervals, not to exceed 30 feet horizontally and 26 feet vertically. Outriggers can also be used to broaden the base and stabilize the scaffold. To provide stability and prevent lateral movement, it is a good practice to secure all scaffolds to the building or structure at intervals of 25 to 30 feet horizontally and 25 feet vertically. Drawings and specifications for all frame scaffolds more than 125 feet in height above the base plates must be designed by a registered professional engineer, and copies of the plans made available to the compliance officer for inspection purposes. Since there are several manufacturers of metal frame scaffolds, the mixing of components or individual member pieces is not recommended, but is allowed if the end frames match, the cross members match, and stability and plumbness are maintained. In no case shall there be any modifications made of any components, nor shall they be forced to fit. Another type of scaffold, the tube and coupler, is often used when a work platform is required to be built around an irregular structure. The tube and coupler scaffold usually consists of 2-inch outside diameter steel tubing used to make posts, bearers, runners, and braces. The runners are placed along the length of the scaffold and interlocked to form continuous lengths and connected by coupling devices to each post for stability. The bearers, which help carry the load, are installed across the width between posts and securely coupled to the posts to form a level base for the work platform. Cross bracing is installed across the width of the scaffold at least every 3rd set of posts horizontally. Diagonal bracing is used and installed at approximately a 45-degree angle from near the base of the first outer post upward to the extreme top of the inner post to maintain structural integrity. For stability, the entire scaffold must be tied to and securely braced against the building or structure at intervals not to exceed 30 feet horizontally and 25 feet vertically. Manually propelled mobile tubular welded scaffold, commonly known as the mobile scaffold, is primarily designed for use on level concrete or other smooth floors, to access elevated work areas, or simply to install equipment or parts. Mobile scaffolds, which are supported by casters, must consist of cross braces and diagonal braces secured laterally to the vertical end sections or members to maintain stability. The cross braces and diagonal braces must be of a length that will automatically square and align vertical members so that the erected scaffold is always plumb, square, and rigid. To ensure further stability and reduce the possibility of tipping, the height must not exceed 4 times the least base dimension. For safe access, ladders or stairs must be provided, either built in or attached to the scaffold. Mobile scaffolds are limited in height to a single unit or section unless the entire system is approved in writing by a registered professional engineer, or it is erected in accordance with instructions furnished by the manufacturer.